for section 2.5 here, we just kind of use the equations, the kinematic equations a little bit more from the last section. There's just a couple more examples that kind of showcase those kinematic equations. However, there's a very, very, very important statement that they make here in 2.5. And by convention, you guys know that typically things that are going to the right we call positive, things are going to the left they're negative, up is positive, down is negative. Every once in a while, we have to actually change what we're going to call the positive direction and the negative direction. And that's fine. You can do that. You can go against convention as long as you have it clearly stated what you're going to call the positive direction and the negative direction. So they say here, decide at the start which directions are to be called positive and negative relative to a conveniently chosen coordinate origin. Okay, so every once in a while, you do have to change what you call the positive and the negative. It's just typically we say to the right is positive, to the left is negative, up is positive, down is negative, but it does not have to be that way depending on how you choose it to be. And concept example 6 here is very tricky, and that's kind of why I put it in here to go over. And it says a car is traveling along a straight road and is decelerating. Which one of the following statements correctly describes the car's acceleration? It must be positive, it must be negative, or C, it could be positive or negative. Okay, and when they refer to it being a positive acceleration or a negative acceleration, that's talking about direction basically. Is it left or is it right? And the reason that this one's so tricky is that if you remember, I said in I believe it was section 2.3, okay, when a vehicle is decelerating, in other words, when it is slowing down, all that matters is that your velocity and your acceleration have opposite signs, okay? Your velocity and your acceleration must have opposite signs. If your velocity and your acceleration have the same sign, whether it be positive or negative, that means your object is speeding up, okay? Or it's accelerating. If an object is slowing down, okay, your velocity and your acceleration will have different signs. And what that does is, should you pick to the left to be positive or negative, whatever it may be, your signs will still have to differ if it is slowing down. So in this case, and this is what makes this one a little bit tricky, a car traveling on a straight road that is decelerating, it could be going it could be a positive or a negative, because it could just depend on the fact that the car is traveling left versus traveling right. Okay, so in this case, and again, I know that it's tricky, but even if it's decelerating, okay, it could be positive or negative. All that matters is that your acceleration and your velocity must have opposite signs in order for a vehicle or an object of any sort to be decelerating. Okay, and they kind of show this here. If it's going to the right, velocity being positive, acceleration being negative. And then you could flip-flop it. Hey, you could say, hey, velocity is going left here, acceleration going right. So your acceleration would be positive versus up here where it was negative. But because it is decelerating, notice that these would have opposite signs, right? No matter what, they would have opposite signs. So that's one of the big takeaways that you got to take from this section, okay? Example 7 gets pretty lengthy and a little bit complicated, okay? So in example 7, it says the physics of a spacecraft retro rockets. Retro rockets are basically just rockets that would fire in the opposite direction to slow something down. So the spacecraft shown in 2.1a, which I'll show you on the next page, is traveling with a velocity of positive 3,250 meters per second. Suddenly, the retro rockets are fired, and the spacecraft begins to slow down with an acceleration whose magnitude is 10 meters per second squared. What is the velocity of the spacecraft when the displacement of the craft is positive 215 kilometers relative to the point where the retro rockets began firing. All right, there's a lot going on there. So what we're going to do is we're going to pull off all the stuff that we know. So as you look at this, you've got a velocity, and it's 3,250 meters per second, which I know that we need to figure out whether that's our initial or our final velocity, which we'll discuss here in a minute. The acceleration we know to be 10 meters per second squared. And it wants to know the velocity when our displacement is, so displacement is x, remember, positive 215 kilometers. Okay. Now remember, kilometer meaning 215,000 meters. Okay. Well, one of the things that you, again, this is where I said physics becomes very, very tricky, is that it says that your spacecraft begins to slow down. Well, if it's slowing down, that means it's decelerating. And if something's decelerating, what's the sign of your acceleration? Has to be negative, right? Has to be negative. So decelerating is an acceleration that is negative. So right here, right, take into account that your acceleration is going to have to be negative. Okay. Well, since we were told that we're traveling along with a velocity of 3,250, and then it wants to know what is the velocity later on at a displacement of 215 kilometers, this here is going to have to represent our v sub 0. So that's our initial velocity, okay? So that's our initial velocity. We have our acceleration. We're looking for final velocity, and we have a displacement. So knowing that we're trying to find v here, right? Knowing that we're trying to find v, what are some of the formulas that we could use? And if you go back and you look at the last section, right? We have a couple of formulas there. Let me go back to them just for matter of reference for you guys. All right, so here's all of our formulas at hand, okay? So the problem being is like here, v equals v sub 0 plus at. Well, that would find me my final velocity, but I have no way of finding this time situation, right? There's nothing in that problem that would allow me to go ahead and find time. So any of these problems or any of these formulas that have time in them, they're unusable because there's nothing that would allow me to find time in that problem, and it's not given. So therefore, the only formula that I can use is this very last one, this v squared equals v sub 0 squared plus 2ax. Well, okay, let's go ahead and use that. And that's what the book's going to use as well. So here's more or less what it's looking like, okay? And we have to use this formula that we just talked about. We said, well, okay, v squared equals, right here it is, v squared equals v sub 0 squared plus 2ax. Well, we have this. Good. V sub 0, got it. We got a and we've got x. Fantastic. So all we need to do is solve for v here. So what you would do is you would take the square root of both sides. But don't forget, when you take the square root of both sides, what has to go? Plus minus. Anytime you take the square root of both sides, you need to do plus minus. So in this case, we can just plug in v sub 0, we can plug in a, we can plug in x, and that's all they're going to do. Look, they say plus minus the root of our v sub 0 we said was 3,250, 2 times, here, 2 times a, don't forget this has to be negative, right? This has to be negative, times 215,000 meters. Now, the interesting part is that we get 2 values, right? We get 2 values. Why? So the velocity, basically, the velocity at 215,000 meters gave us two different answers. At 215,000 meters, my velocity is going to be both positive 200 or 2,500 meters per second and a negative 2,500 meters per second. Why? Well, imagine, if you will, okay, just what they have drawn here. Basically, what's happening, okay, is this object is going along, this aircraft, this spacecraft, is going along, and in order to slow it down, the retro rockets essentially fire in the opposite direction in which it is heading. So what's going to happen, let me get rid of all this stuff that we have written, and what's going to happen is it's going to begin to slow it down. And that's where you're going to come up with the first answer, right? You're going to get the first answer, and you're going to come up with one answer, which is positive. But then those rockets, it doesn't say anything about shutting off. So what's going to happen is that rocket is then, or that spacecraft is then going to be going in the opposite direction. So you're going to get one velocity when it's 215,000 kilometers one way, but then you're going to get 215,000 kilometers the other way. So you're going to get both a positive velocity and a negative velocity. Okay, that's why you end up with the two different answers. Okay,